All right. How's it going, everyone? Hope you are having a wonderful afternoon. Ready to get this bad boy started? Ready for tomorrow's quiz. Hello. All right. Start. I got a couple questions for you guys. Throw these out while we are looking for people to join. What's up? Hey, Zon. Welcome back. I'm glad you're ready. You got this, Abby. You'll be fine. Hey, Fatima. What's up, Christine? All right. Boom. First question. Easy peasy. Get you settled in. This was a long time ago, Zon. We won't hold it against you. We are not looking for sensory adaptation on this one, Emma. Good thought, but that's not what I'm looking for. Ooh. Ooh. Struggle bus. Come on, boys and girls. Although Robert was sitting right next to his wife, he smelled a skunk minutes before she did. Apparently, Robert has a blank for skunk odor than his wife. What is happening here? Yeah, there we go, Grant. Absolute threshold. Yeah, definitely. So you're looking at I think you guys might be, avoiding absolute threshold because it's such a strong actual smell. But basically all that's happening is he is smelling this thing before his wife does, and they're sitting in the same place. Yeah. Yee. That's what we're looking for. Okay. Okay. There we go. Well done, Grant. Well done. All right, here we go. We got some more. We got some more. Boom. Just remember, if you guys have questions, I'm here. I am here, boys and girls. If you have questions for me, throw them at me. We got a bunch of people on. Oof. Yep, this one's the sensory adaptation. Good. Yep. Everyone's here. Coming out of the rabbit holes. Shush is on. You didn't get the first one. And you didn't even know the second word of this one. All right. There we go. What are the things that could be? Grant. I had that posted on the board. Bunch of stuff. Let me see if I can pull it up. All right. So on the FRQ tomorrow, let's see, what is it? Figure and ground, rods and cones, gate control theory, vestibular sense, selective attention, and then monocular cues. Those are all of them. I'm not gonna type them up. I still weren't even the first one is on. Will there be any labeling? Yeah, Abby, there might be. That's fair. Labeling of the eye and the ear is fair game tomorrow. So you need to know where those things are. So perception is correct. Yes. It is so when you are looking at your vestibular sense, like it is your sense of balance. Like your ability to, not fall over, anytime that you are just walking around. Um, and it also helps with like how you want to say it, like your spatial orientation, like whether or not you are like flipped upside down or something like that. You know where you are. So, um, I mean, once again, you kind of your biggest example of that is just spinning around in a circle and getting off. I mean, and getting off balance. You also have like when you get an ear infections. If anyone's had ear infections before, oftentimes um, a symptom of ear infections is nausea or just feeling dizzy. So, yep. If that's still like confusing you, maybe I can kind of give some more examples or whatever. But that, I mean, that's just what's going on. So, yeah. Aleem, if you're still confused by that, let me know. Okay, so uh, no, Calvin. There's Calvin. Word bank for what? Okay, so uh, yeah, your vestibular sense is in your ears specifically. In the like the area above the cochlea. There's like a little area, the vestibule. Okay. Yeah, gate control. Oh, can you explain cones and rods a little bit more? Yeah, Hadia. Yeah. You just need to recognize what that rods and cones are your ears, or not your ears, your eyes' sense of sensory receptors. So that's what allows you to pick up different colors, pick up motion. So light is traveling into your eye, and those signals are hitting your cones and your rods, and those rods and cones pick up that information, and transduction change those light waves into neural communication and action potentials. And so your rods are good at picking up movement. Your rods are good at working in dim light. They only see in black and white. And then they're in the peripheral areas of your eyes. Your cones are in the center of your retinas, and they are what you use to like look into, like focus in on certain items. So if you're looking at a cup or something, you never do this, like, ooh, look at all the fine detail or whatever, because that's where your rods are. Your cones are in the center, and so you'll look in and you'll bring it up close or whatever. So, um, okay, good. So if you still have questions on the rods and cones, cones also do color, obviously. Okay, and they're not very good at in darkness. All right, gate control theory. Sure, sorry. So, just don't overthink about it. Gate control theory is basically just this idea that, hey, if I'm hurt, I don't have to stop. Pain is just a object, or is just um, a tool of the brain to get you to stop doing what you're doing, to check out, hey, there's something wrong here. So if I can recognize that something's wrong, but then make a decision like this other thing is more important, so I'm just going to keep going. And so it basically shuts off those pain signals and allows you to play through or to do whatever you want to do or whatever you need to do. So that is gate control theory. Okay. Um, Ooh, I'm falling behind. So what is the difference between relative clarity and light and shadow? Um, think Talia, think of like relative clarity as like fuzzy. Like you let's see. Like, okay, so the walls in my room. So you see the walls in my room as just like blank, but they're actually textured, and if you like got up close to them, you could see all of the texture. But because they're so far away, you're not able to see it very well. Let's see if I can do this. All right, so I have here. Oh, that's not a good example. All right, so I have so I have here a Magic the Gathering card. Let me pull up my other screen. So I have here a Magic the Gathering card, and so maybe the back's easier. Okay, so it's sorry, my light. So it's easy to see like a lot of the content and like what it says. You can read Magic there, but as I get farther and farther away, that detail is gone. You can't really see any of this stuff anymore. Oh, hello, Teddy. You can't really see any of the details of this, like the picture as well. Like what's on this picture is not really there anymore. You just see like little lightning bolts. Whereas before, you could see all of the different um, like it looked clear or whatever. So and then light is just saying things that are farther away are darker because less light is being reflected. They play off each other, like they influence one another. So yeah. All right. Are people answering my questions before I can get to them? Yes, this will be on the AP exam. I have no idea what a fry prompt is. Are you talking about an FRQ prompt? No, Sahil. I cannot give you an example of an FRQ prompt. You will have to find that out tomorrow. Um, yeah, that's good. Yeah. Thanks, Emma. I was a little slow. No, what? No, you guys don't. No, what is that no for? Look at this. Magic is cool. Listen. Magic the Gathering is fun. I like Magic the Gathering. It's a cool card game. See, Teddy likes it. He's all about it. See, you got little cards. They have cute pictures on them. Yeah, thank you. See, Teddy likes it. That's cool. Rawr, Pyromatics. All these cards are great. It's good stuff, man. Hey, listen, you got to find things in life that you enjoy, and just embrace it. Don't let anyone tell you otherwise. Thank you, Azan. I appreciate that. No, Teddy loves them. He thinks it's super cool. He loves it when I don't pay attention to him and and play card games. Listen, it takes one to know one, Emma. It sounds like I'd like whoever your boyfriend is. Right, Teddy? That's right. Listen, you guys are saying these things like it's a bad thing. Like, how long has it been since nerddom was like kind of the cool thing? Like, listen, how many comic book movies are out right now? Marvel, DC. Listen, that's. I mean, I didn't take it as an insult when it was an insult, and now being a nerd definitely isn't an insult anymore. Yeah, Shanze. Yeah, we can go back and focus again on what we're talking about. I was just dropping knowledge on these haters, right, Teddy? Haters. If you ever want to play Magic with me, Calvin, and we're not doing school stuff, I'm down. Teddy is hungry. He's perpetually hungry. All right, Shanze. So what we were talking about specifically when we were dealing with the dealing with bad eyesight, all we were talking about was accommodation, which is that process of the lens changing shape in order to allow us to focus in on objects and items. And so what ends up happening is people that have whose lenses aren't properly accommodating is that well, is their perfect image doesn't hit the retina properly. So this is the back of the eye. So you have your eye here, correct? And this is the back. This is the retina. And so the retina is here, and this is where all the rods and cones are. And so when I'm just going to kind of blow this up. Let's say our eye is this big. So when the lens reflects that light, that perfect image back to the retina, if they have 20/20 vision, like me, Mr. Monk, if they have a vision like Mr. Monk, then that image will lay perfectly on the back of the retina. However, what ends up happening is you have people um, whose eyesight's not 20/20. So if that person is nearsighted, that perfect image, instead of hitting here, it's here. And so by the time it does hit the retina, it's spread out and it's too big, and so it doesn't look properly. It's blurry and just out of focus. And that's why I was using the projector. Like, you change the settings on the projector. What you're doing is you're changing where is the blackboard, where's the whiteboard that it's supposed to be projecting onto. And as you change that, that focus is changing where that thing is. And so it goes out. Okay. Goodbye, Azon. Hype train never left. Okay. So I don't have Shantae, let me know if that works for you. Calvin, I'm so proud that you do like magic. Fatima, they're not dolls. they're they're what we would call miniatures. So plastic miniatures. And whatever, you're jelly. So jelly. All right. Can you lend me some magic to get my internet to connect, because I'm struggling? I cannot help you with that. I know Magic the Gathering, the card game, not actual Magic. All right. No, I mean, you don't need to know the specific percentages. I just use it I just say them to sound smart. Example of difference threshold. I can give you a bad example of difference threshold, but I can give you an example of difference threshold. Hold on, let me get my Dungeons and Dragons books out. Okay. I am hyping up. All right, so this is I love my life. Okay, so this is a silly example because it's not very good. Okay, so let's just pretend that these two colors, like this purple and this purple, were really close. Like, they were almost the same. Almost the same thing. I'm just gonna start bringing out all of the nerdy stuff I do, or all the nerdy stuff I do, all my board games and stuff like that. Okay. Yeah, Reeb, give me a second. Let me finish this. Okay, so when we're talking about the difference threshold, what we would be saying is like, hey, this right here, these are so close together that you can barely tell the difference. These shades of purple are almost the same. And so it's just like absolute threshold, where it's that minimum level of stimulation to actually see or hear or sense the thing. And it's the minimum level of difference between these two. They're so close that you can only tell that they're different 50% of the time. So that would be an example um, retinal disparity. Goodness gracious! Wait, is that what you asked? Hold on. Yes. Okay, Fatima, I answered your question. Okay, cool. I jumped ahead and read Shanzai's question. I'm like, oh gosh. All right. What's the difference between? Okay, give me a thumbs up if that's good. What's the difference between nearsightedness and farsightedness when it comes to getting the photo back to the retina? Oh, yeah, yeah. Remember, nearsighted, the perfect image is going to be here, and then farsighted, the perfect image is going to be back here. And so yeah. No, you don't need to know that. But that's what it is. Binocular cues mean to view things from your two eyes while retinal. Sarah, uh, uh, Naomi, did you ask a question? Did I miss it? Naomi, you asked what's the difference between I'm sorry, Naomi. Thank you, Sarah, for stepping in, but it's not totally right. So binocular cues and retinal disparity is an example of a binocular cue. So you know how we are like monocular cues, we have relative height, relative clarity, interposition. We had all of those things. Those are all examples of monocular cues. Retinal disparity is just the only example of binocular cues that you need to know. So once again, binocular cues, or not binocular cues, it's recognizing depth with two eyes. Retinal disparity is the fact that your eyes compare the difference between the distance of the two images that your eyes put out. So your eye is I'm looking at the light bulb that's in front of me, okay? And my eye is measuring that distance from my right eye and from my left eye, and then it compares the difference between those images and helps me perceive how far away it is. Ooh, Settlers of Catan is a good game. Okay. Oh no. I mean, I don't know if I'd say this is my favorite stream, but I've been enjoying myself immensely. I'm a little bummed that I don't have other nerdy. I'm trying to think if I have other nerdy things in this room. No, nothing else. I mean, I just have books and stuff, but those are just normal books. Hmm. All right. What else you got? What else you got? Bring on the questions. This book is so good, by the way. It's a really good story. It's about vampires and stuff. It's awesome. Oh yeah, yeah. I mean, I've got more questions. I'm sorry. Yeah, sorry, I can do that. Let me post a first question, and then I will. Okay, so just remember, Sarah, Visual Cliff is just that experiment that a bunch of guys did in order to study when we get our depth perception. That's all that's going on. And it's in the end we found that it was mostly garnered at the age of 3 months or so. So our change blindness and yes, there are the reason why we have change blindness and intentional blindness is because of selective attention. Okay, I think someone asked me about the different laws before, and I didn't answer that question. I apologize to whoever asked me. I'm just now recognizing that I think someone asked me about the different laws. Okay, law of proximity. All law of proximity is saying is that things that are close together, our brain sorts as together. Like you. Okay. It's art time. Okay. So you have 6 lines. Okay. So you have 6 lines, and basically all this is showing us is that which of these lines, do you like? You don't see these as 6 individual lines. You generally see it as, hey, these here are 3 individuals, and this is like a trio of some sort. So things that are close together, we just see as together. Okay. And then similarity is just talking about like, hey, when you see things that are similar, we pair those things together. Okay, so I know this is kind of similar to the example I had in class, but we see these as horizontal lines and not vertical lines because circle, circle, circle makes much more sense than triangle, triangle, or circle, triangle, circle, triangle. So, okay. Rods and cones, good. Can you go over wavelengths and the colors they produce? Sure. All right. Actually, we'll do. This will be my next question. Rods and cones is good. Good. Kinesthesis is just your understanding of where your limbs are when you're not looking. So close my eyes, I know where my hand is and my arm is and stuff like that. I'm going to go over the wavelength thing in just a second. That's it, Fatima. It's not like, that's it. You know where your limbs are when you are not, when you don't have to, and you don't have to look at them. Okay, Naomi, was it you that asked that? I'm sorry. Okay, law of common region. Once again, all this is like, hey, things that are in certain area, things that are boxed off and squared off, we just put together. It's so like it like, don't look for the extra hidden meaning behind it. It is what it is. This goes together because it's inside a box. Okay, I've done law of proximity and law of similarity. I did, yeah, things that are similar we put together. Yeah, they are familiar. But proximity is just this thing is close together. Similarity is these things look the same, and common regions is it's inside the same space. It's inside the same box. So, okay. Thank you, Abby. Uh, uh, hey, I don't understand what we're talking about. So I went to Schoology, and in the vocab, there's some stuff we didn't go over. No, that's just like stuff that, like, okay, so Hadia, to I'm gonna come back to drawing here in a second. Hadia, the drawing, like the vocab on Schoology, basically what ends up happening is that, like, there are tons of textbooks. They all have different vocab words. I just use the ones that I think are best suited, or the ones that I see the most often. So, for my quizzes, don't worry about the flashcards. That'll be more for studying for the AP exam. Okay, so okay, so let's do waves. All right, so I see. Actually, let's just do this. So ignore. Let me see. Do I have a black Sharpie? I do not. Oh, I do. Oh, it's not very big. Is this? Are you gonna be able to see the silver one? Not really. Why do I have so many Sharpies in here? Is this big enough? It'll be fine. Okay, cool. All right, so let's. Aman, I'll come back to the question about the ears. So, okay, here we go. So we have wave. We'll do wave number one. Nope, this isn't gonna work. All right, sorry, I'm gonna have to just do a color. So, all right, so here we go. Wave number one. Let's do a fresh sheet. All right, wave number one. Looks like wave number one looks like this. Let's go sound. This is sound. What is the sound? What sound is being emanated here? What do you want? You don't need attention. Are you gonna come up? No, you're just like, no, we're not playing right now. Oh my gosh. Two things. I need two things. I need both. It's hello. Yeah, so if it's high frequency, Emma, what is it? Yes, it is a soft sound. Hello, Eduardo. Why are you on here? Soft and high. Soft and high. So it's soft because remember, sound is amplitude and frequency is pitch. Okay, so now what color is it? So now switch over. What is the color? So same thing, color. What color is this? Good, yes. Dull blue, good. All right, next one. Okay. What color is this? Blue and dull. Yeah, yeah. High frequency is blue. High frequency is blue. I know you're hungry. You only ate 3 hours. You ate only a total of 3.5 hours ago. You must be miserable. Cerulean blue. No. Um. Uh. No. This is not dull. This is bright. This is bright because it's high amplitude. I know it's hard to. Sorry, it's not red. This would be the middle one. It's probably the best way of doing this. Yeah, is to what? No, we just went outside. You just chill. You have to wait till my stream's over. So this would be a bright red here. This would be a bright red. Yeah, I would say the other one was a bright green. I'm not going to put pictures up for you just because it would be difficult for that to make that. So, what sound is this though? The bottom one, number 3. What sound is it? What's my sound? What sound is this? Yeah, low and loud. Low and loud. Or yeah, low and medium loudish. So cool. All right, there's your wavelengths. So remember, amplitude, the height of the wave, how high it is, that is both for sound. For sound, it is how loud it is. Okay. And then for color, it's how bright it is. So the higher the amplitude, the brighter. The lower the amplitude, the more dull it is. And then, what I said? Oh, it's high. Oh, I'm sorry. Did I just say yes? No. Yeah, that was high. It was high and low. High and low. High sound, low speak. Yeah. Yeah, sorry about that. Sean said good catch. It's high in sound because amplitude was big. Well, I mean, I don't know. Yeah, this is why drawing's hard, guys. Drawing's really hard. Yeah, I mean, I get it's louder than the other one. So, dude, I'm about to set you outside, and then you're gonna want to come in 5 minutes. Is that what you want? Do you want to go? Okay. Let's go. Out you go. Just know you're gonna want to come back. All right. Okay. All right. What do you guys need? What else? I'll post another question. Bam. Oh, let me go back. I think someone asked some questions before I'm going to answer. Yeah. Imana. Okay. Imana, I'm going to come back to that. And Sarah, yeah, Sarah, I see your picture or your question. Okay, so so let's just go through the process of hearing. Here. Okay, does that work? Okay, so here we go. So when we are looking at this, okay, so you have sound waves that travel in. They hit your pinna here. This is also calling it the auricle. Oh yeah, it also is called this, but we call it the pinna. Don't worry about that. I don't think they'll call it this. Okay, so it hits your pinnacle, your pinna or your auricle, whatever. Sound waves come here. The sound waves reverberate and are funneled into the auditory canal, bounces around inside the auditory canal, hits the tympanic membrane, also known as the eardrum. Remember that eardrum is just like a bit of skin that's tightly stretched, and that turns those sound waves into vibrations. Those vibrations are picked up by the malleus, incus, and stapes, which is the hammer, anvil, and stirrup, and those vibrations carry on to the cochlea. Cochlea begins to vibrate. Inside the cochlea, we have fluid and hair cells, and those hair cells begin to vibrate along with the not the hair cells. The fluid begins to ripple, and the hair cells pick up those ripples and then sends it on to the auditory nerve that sends it off to the um, temporal lobe of the brain. Bam. Okay. Uh, yeah. So spatial orientation is just like recognizing what is around you. Like and just like maintaining our body position. So if you're like in a plane and they like flip you upside down, like we're gonna recognize that we're flipped over. Um, uh, I mean, it's just like our ability to maintain natural body position. So like helping us with like our posture, and also kind of dealing with our like recognizing our surroundings, our physical space around us. So um, that's like that's all it's really talking about. So does that make sense? Is that okay? Okay. Yes, it is the multiple choice kind of labeling. All right. Next question. Law of closure, very good. Yep, law of closure is what I'm looking for. Good stuff, guys. Good stuff. All right, next question. Boop. What did you ask? Yeah. Wait, Calvin, what's your question? Whether or not, yeah, everything's multiple choice. It's always multiple choice. Linear perspective. Good, guys. Good. All right, next question. I explained law of similarity. Yeah, when things that's what the triangle circle triangle was. Law of similarity. This is why we see these as horizontal, not vertical lines. That's law of similarity. There you go. Good. Transection, guys. Yep. No questions. Question marks, Iman. Be brave. No question. Definitely not ... question mark, Emma. Once again, be brave. All right, here we go. Next one. You might be. I would never make a mistake, Calvin, so it's definitely not me. Never made a mistake I could remember in my entire life. Do we need to know everything in the AP exam 5 sensation? No. No, Abby, once again, like I've got to have materials for like my first semester students, so a lot of that is in there. You already know what the cocktail party effect is. That's just an example of selective attention. Cocktail party effect. You are sitting at your house, or not your house. You're in the cafeteria talking to all your friends, and then you hear your name, Abby, in the background. You turn and you look over. Why did you hear your name? There were so many other conversations going on. Why did you hear your own name? And that's just the cocktail party effect. Like we like ourselves a lot, and we like our names a lot too. So when other people say them, we look. So yeah, Fatima. Transduction is just changing of one type of energy to another type, which is exactly what's happening with the eardrum. Sound waves coming in, okay, that's energy, okay, and then it hits the eardrum, and the eardrum begins to vibrate. That's another type of energy, and so the sound waves become vibrations, and those vibrations eventually are picked up by the receptor cells, which are sent into action potentials, which go and send messages to the brain. So it's all these different types of changing of energy. That's how we sense the world around us. So difference threshold is what I'm looking for, boys and girls. Good. The question about transduction said physical stimulus. Yeah, light waves are a physical stimulus. Sorry, it's physical. I mean, what else isn't? Difference threshold, yes. Do we need to know place and frequency theory? Do you need to know place and frequency theory? No. No. I'm done talking about place and frequency theory. I used to teach it, but it's stupid, and I've never seen it on the AP exam, so I'm not talking about it anymore. It's dumb. Okay. What about it, Talia, are you not understanding? Okay. Like, another example of transduction is any type of what? Okay, yeah. What do you not get about it? What is confusing you? Good. Kinesthetics is correct. All right, let me put up more questions. Tully, I'm still waiting, girl. Like you gotta give me a little bit more than that because I'm really not sure. Yeah. So, another example of this would be like photosynthesis. You have like um, plants taking in sun rays and turning those into whatever energy plants use. I don't know. I'm not a biology major, but they take in information or they take in that energy from the sun and convert it into sustenance food or whatever. The sun like the waves that the light and stuff coming in from plants use chemical. Yeah, but they take in that's what like photosynth. Thank you. Yes. Yeah. Well, they're converting that sun those waves into chemical energy or something. Is that what you're trying to say, Emma? Calvin, saying words does not explain things. What do you glucose? What about it? Okay. Right. See? See? Thank you, Emma. We know what we're talking about. All right. Boom. See? I just know stuff, guys. Thank you for that. Thanks for the support, Hala. Thanks for the support, Emma. Yeah, there you could Talia, there's 5. I mean, you once again, your sense of pressure, you're taking that's friction. That's a type of energy, and that energy is being transmitted into um, signals that's telling your brain, oh, you have pressure here. So okay. Sorry, that was a text from soccer stuff, so I have to check it. Well, we are not gonna guys, we need to get it. Let's move away. No, Fatima, we can't see Teddy because Teddy wanted to go. He wanted to go outside or outside my room. So he's he'll see if he can try to get back in. Teddy has already said hello quite a bit today, so he's cut off. All right. Let's see. Mm-mm-mm-mm. Teddy's just has lots of energy and wants to run around. Yep, that's it. That's all you need to know about it, Hadia. Booyah. Thanks for the help, guys. Thank you, Abby. Thank you, Shanze. Yes. All right, we're on a little backlog of trains. I haven't been. You guys have been. See, this is the thing, guys. I need help throwing trains at people. Like if someone answers a question, like that should be instead of saying thank you, you should just throw trains at them. That'll be like our new thank you. Like, oh man, thank you so much for answering this question. Trains. That's how we're gonna do things from now on. Shanze, all of the different. This is actually the last. This is the swan song of Gestalt psychology. We won't see these Gestalt psychology anymore. This is the end of it. So yeah, we're moving on to other things. Yeah. Um. There we go. That's a good question. That's the only thing we could ever hope for, Abby. Any part Fatima. It could mean any part. It could talk about the eardrum. It could talk about the pinna. It could talk about the cochlea. All of those things. Any of those things. Any and all. Yes, Talia. I do progressive testing. No, you gotta do the. You don't just shout trains, Iman. I have not trained you well enough. You post train emojis. Train emojis. Good. Yep. Looking at amplitude. Good. Sorry, I am looking for a question. I've run out of my questions. Here we go. All right. Well, amplitude deals with loudness in sound. Yeah, Calvin, if you want to post a question, I'm fine with that. Amplitude has to deal with Christine, not the part that adjusts it, the opening. Yes. Thank you, Emma. I'm sorry, I was mumbling through that. There we go. Fatima! Yes! Trains for Fatima. Bam! Because she is throwing out trains. Good stuff. Pupil is what we're looking for. Yes. Mm. Criminy. These questions are garbage. All right, I'm out of questions. I'm gonna stare at the screen awkwardly while I look for questions. Sure, Shanse. All right. I'll color coordinate this one. All right. So let's start with color. Boop, 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 boop. All right. So when looking at wavelengths, red looks like that. Green looks something like this. And blue is like this. So specifically, these are the wavelengths for color. So red is long, blue is really short, and green is in the middle. Okay. And remember that when looking at amplitude, amplitude is brightness. So the higher it is, the brighter, and the less high it is, the more dull it is. Bam. And then when we're talking about sound, amplitude is just how high a sound is. And then the frequency is talking about its pitch. The smaller the frequency, the higher the pitch. The longer the frequency, the lower the pitch. Abby, thank you. Thank you. You are the bomb. Answering questions. Emma's answering questions. Bam. Thank you, Emma. Oh, Ethan, can you go over the opponent process theory? Yeah, sure. Give an example of perceptual set. Sure. Don't be scared. Thank you. Oh, emotional support. Love it, Emma. Love it. Emotional support. Fatima, all the trains for you guys. Emotional support is what we're about here. Care about each other. Help each other out. You can do this. You got this. That's why you're here. You're going to do great. Okay. So let me start with the opponent process theory. I want to see if I can get a good picture for you. Okay. So basically all that is happening is you are having these, just transferring you over to pictures instead of faces. Okay. So what is happening here is you don't need to get into all of this fancy stuff. But remember when we're looking at the trichromatic theory and we were talking about, oh hey, short wavelengths, medium wavelengths, long wavelengths, this helps us see these colors. And so what ends up happening is these colors kind of like combine together, and what you end up happening is you have these opposites, and this blue and yellow are opposites of each other. And so what ends up happening is you have um, cones that specifically turn on and off. So you have cones that are dealing with, oh no, why did I just do that? I didn't mean to do that. So wait, what happened? Anyways, so you have cones that turn on and off when this happens. So you have your when you see blue in color, the blue one turns on, and then the ones that are yellow, the red and green, those turn off. And so what ends up happening is your like when you see blue, this turns on, and not only does this say neutral, but this turns off. And so that's one of the ways that we differentiate color, and why we have difficulty seeing colors that are like bluish yellow or reddish green or something like that, is because they don't play off each other, and you just can't. They don't combine together because they're opposites. And it's a good way of seeing like or understanding what's going on with people who are colorblind. It's one of the ways in which this happens. So no failing quizzes, not allowed. Okay. Yeah, okay, so sorry, I was looking over this. Okay, so perceptual set is just talking about your past experience and how that influences um, your decision making. So one good example of this are um, people in law enforcement. So people in law enforcement are often are trained to deal with people with weapons and firearms and stuff like that. And so what you have is you have someone who's a law enforcement agent, and then you have just a normal person, and you flash a picture in front of them that goes really, really quickly of a person that is holding an object, and you flash it at them very, very quickly. And so you don't get enough time to really look at what's in the image there, and so when you ask the law enforcement, the police officer or whatever, what did you see? Oftentimes, what they'll answer is they'll answer with some type of weapon, gun, knife, something like that. And so all that is saying is that when you see things, when you interact with the world, your background heavily influences the way that you see things. Um, so let me know if that makes sense. Yeah. Oh, you need the green wave example? Sure. Green wave was in the middle. Might be hard to see with the light. This is the green wave. Just normal. Thank you, Abby. What do you mean? Yes. Yes. Okay, cool. All right, guys. Any final questions before I duck out of here? Any final wades? Tomorrow's quiz, you guys will do great. I don't think it's one of the harder quizzes. I think it's definitely easier than last week's. Yeah, don't die. Just continue to breathe and continue to, you know, you know, have a heart rate. You'll be okay. All right. Well, that's gonna do it for me, guys. I'm gonna get out of here. Y'all have a great day. Make sure that you don't stay up too late tonight studying. Go to bed. And we'll see you guys tomorrow. Great work. Thanks for hopping on. Have a good one.